Let's go. Okay, our last presentation and the best, Gemma from ARM.
Last but not least, right? All right, so my name is Gemma Paris, and today I'm going to cover mobile phone platforms, or mobile platforms as a whole. And for this, I'll introduce the ARM technology, because as you might be aware, the ARM technology is available virtually in any mobile platform. So in order to know about mobile platforms, I'll introduce you to ARM technology, and then the advances we have on mobile platform technology, and finally, how you can get the most out of these mobile platform technologies so you can achieve high-quality graphics on mobile. Right, so we'll start about ARM then. How many in the audience have heard about ARM before? Hey, that's pretty good. Let's see if you guys knew about all of this here then. So ARM, the main core technology of ARM is the processor IP technology, which is based on RISC architecture, which is reduced instruction set computing architecture. And that means that the low power, it translates in low area and low cost. So those are the three key ingredients to be successful, to be the platform of choice on mobile platforms, compared to the CISC architecture, the complex instruction set computing architecture that's available on desktop. And if we go onto the mobile platform here, you can see that actually looks like a PC motherboard with lots of different components. And the main component that you can see is the apps processor, so the CPU and the GPU from ARM. The CPU from ARM is the Cortex family, and the GPU is the ARM Mali family. However, ARM technology is not only in the apps processor. You have a lot of ARM IP around the phone. So all of these little bits and pieces around are also ARM technology. All these microcontrollers that run the Bluetooth protocol stack, for instance, the Wi-Fi controller, GPS, etc. So there's ARM IP, very abundant in any mobile device. However, you as a game developer, what you need to care about is the apps processor, about the CPU and the GPU. And one of the latest processor technology that we have for the CPU is that we use a big core and a small core, we call little CPU. So the big CPU does the more complex task and consumes more power, and then the little CPU does the more mundane task and consumes very, very little power. And then between those two cores, we have this interconnect IP, and there's the technology already available automatically, so you don't need even to worry about it. And it does, depending on the app, one core runs or the other core runs. And apart from this, we have this interconnect IP as well that links all the different IPs within the apps processor, the GPU, the CPU, and other bits of IP, depending on the apps processor. And for you to bear in mind that this year, what you find in the market of ARM big little architecture is for big cores, the Cortex A72, and for little cores, the Cortex A53. And then for graphics is the ARM Mali T880. Also at ARM, we have Enlighten. And Enlighten is dynamic global illumination technology. And as you know, this is the conglomeration of having direct light illumination with indirect light, and then that does the global illumination. One of the key features is that it only pre-computes Enlighten the location of the static geometry, and all the rest is computed at runtime, and it achieves realistic and high-quality graphics that way. And all these leading titles here use Enlighten already. Those are just the leading titles that we suggest: Battlefield, Plants and Zombies, Need for Speed, you name it. Also, this Enlighten technology is available, is optimized for the mobile platforms, but you can also use it for desktops, for consoles. It is also available in Unity 5, so you have Unity 5, the global illumination technology there is from Enlighten. It comes pre-integrated in Unreal Engine like a plugin, or you can license in as a standalone with an SDK if you have your own proprietary engine. Right, and now I wanted to show you the ARM business model for a couple of reasons. The first one, it might inspire your business and you might copy it. The second one is because this is what it shows us, how the mobile phone and the mobile platform as a whole market evolves. And we have a very clear visibility of it, thanks to that business model. So first of all, we have the engineers that do the research and development on the next processor IP architecture during 2 to 3 years. And after this, we have our licensees, like NVIDIA, Freescale, Samsung, etc. And they pay a big license in order to use our processor technology and start building the chips. So as we do not manufacture any chips, it's our licensees who will do the chips. And then the licensees, together with the ecosystem, they do the system integration and they will manufacture the device. So after 2 to 3 years, the device will be ready, and that's when we get as a royalty per device shipped. And our licensees need to give us a report every quarter of the number of licenses that they have sold, they have been shipped, and the forecast. And this is why we have a very clear picture of where the mobile market is heading. And we share this with the industry, so no worries. And another thing I wanted to point out for game development is good that you know about ARM Mali GPUs. It's the world's first graphics processor in shipments. Last year alone had 750 million shipments, so it's impressive. It's already in 75% of digital TVs, 50% of tablets, and 40% of smartphones. We started the design of these in 2006, so less than 10 years after. This penetration is quite impressive. Right, now that you know a bit more about ARM, we are going to go to the technology advances. So first of all, I want to put you on the market in 2020. How many smartphones will there be in the market by then? There will be 2.3 billion smartphones compared to the Microsoft-enabled devices in the last presentation, to 170 million. So that you can see the difference. And smartphones are differentiated between 3 categories: the premium, the mid-range, and the entry level. So the premium would be like this Samsung Galaxy S7 now in 2020. Let's see what it is. Then the mid-range is the range of mobiles that cost around $200, and entry level is $50 to $100. And for you to get a bit of an idea, the premium smartphones of today, in 1 to 2 years, they are going to be mid-range smartphones, and in 1 to 2 years, they are going to be entry-level smartphones. So the Samsung Galaxy S7, which was launched last month, in February, so a month and a half, will be an entry-level smartphone in 2020. The lifespan of a phone is 2 years, so this market evolves very, very rapidly. And another thing to take into account, have you seen the number of tablets? Almost 500 million 2020 in that year. And you see the number of laptops. There's a big difference. Laptops are not increasing by the rest of the numbers. And this includes also the 2-in-1s, which are hybrids between tablets and laptops, with the clamshells. So today, what we have is the computing power of mobile platforms is shown in this purple line. And you can see that we are not far from the Xbox and PS4 computing power. We, around 2017 to 2018, we are going to reach that computing power. And what I put in dotted line is the straight line, which shows like the mobile computing power follows also the Moore's law, which is quite interesting. And as you may know, Moore's in the year 60s said that every 2 years, the amount of transistors in a specific area would multiply per 2. And it looks like also the computing power of mobile platforms follows the same law. So it's quite impressive. All in all, you can achieve high-quality console games on mobile platforms. However, there's the bandwidth, and the bandwidth doesn't progress that fast. And why? Because this means power consumption. It does progress, but not as fast as the computing power. And as you can see, the mobile platforms compute uses about 3 to 7 watts. And if you compare to desktops and consoles, that's nothing. It's quite impressive what you can achieve in such a tiny, low-power device. Another technology trend from these years, the last couple of years and coming, is the big little. That's what I've been telling you about ARM, very predominant in the Android world. We have the little core and the big cores, and those two, one does the complex task, the other is the simple tasks. You don't need to worry about it. It is done automatically. However, for the next trend, you do need to worry about it, because ARMv8 is the new architecture that last year already around 50% of the new smartphones were shipped with the ARMv8 architecture. And the key feature of our latest ARM architecture is that it enables 64-bit. So I encourage you as a game developers to start porting your applications to 64-bit. And one of the benefits is that if you already have an application that runs 32 bits, then don't worry, it's backwards compatible, it will work. Your games already exist. However, if you want to benefit from the advantages of 64-bit, then I encourage you to build it and compile it for 64-bit. And like this, you will access an extra number of registers, and you will be able to address a larger memory space, so you can load larger assets, so your gaming can be more powerful. And also you can benefit from all the new instructions that the ARMv8 provides, like the crypto instructions and more advanced SIMD extensions, etc. Also, another advanced technology that we are seeing is that phones more and more have a higher resolution. The average phone has 1080p resolution. Can you believe it? Full high definition. And we have also seen phones and tablets with 2.5K resolutions. And if you compare it with these big humongous televisions that they claim to be 4K, they have like around 8 million pixels, right? And a small Google Nexus 10 that is already 3 to 4 years old has 4 million pixels in that area. So all in all, it's like you have 50 times more screen space, and you just have double amount of pixels. So the amount of pixels, resolution, and processing power you have is impressive. And as you know, VR now is becoming, VR and mobile VR is becoming more and more predominant, and we believe that the resolutions are going to go even higher because of VR. So 4K, it will appear on mobile very soon. And another technology trend that I am very happy for you guys is the new graphics API, the Vulkan API. So before Vulkan, you had OpenGL for desktops, and you had OpenGL ES for mobile, which was a subset of APIs from OpenGL, because the computing power was a bit different, and we were thinking the industry, it was not ready, the platforms, to have a joint API. But now we are ready, and there's these new APIs, so you just need to code for one single API, and you cover cross-platform. And it is already available in the Samsung Galaxy S7, and there's a very nice Protostar demo that Epic Games and Samsung jointly did with our support, and is running on this phone. So after, if anyone wants to come after, yes, I'll just open it here, maybe on the background, and then I'll show you at the end. Now loading. So, and features from Vulkan, other features is that it allows developers to access the memory management, and before the APIs did not allow this. And also you can have direct control on the GPU, and therefore you can optimize much better for any hardware platform. Gives you more flexibility. It also is multi-threading friendly, and the latest phones are multi-threading. They have more than 4 cores, even CPU and the GPU. And also it uses the SPIR-V shading language, which simplifies, makes the drivers very, very thin, and that's because all the extra power is done onto you. You have direct control onto the hardware. So how can you achieve then the high quality graphics, and what do we have for you guys? So what ARM provides for you is a set of tools for free that you can download on our website. That's first to start with, because in order to achieve your performance, first you need to know if your code, where the bottlenecks of your code are. So the first tool I would recommend you to use is a profiler, and we have the Streamline. We have a free version you can download. And here it finds the workloads of this. It tells you what is the bottleneck, if your CPU or your GPU vertex shader or the fragment shader, or is the bandwidth that you need to tackle. And after this, we have the Mali graphics debugger that debugs, traces all the API at the API level and tells you exactly what is the bottleneck. And then you have also the offline compiler in order to optimize your shader code. You have the OpenGL emulator in order to emulate the mobile environment onto a desktop. And then you have the texture compression tool that I really recommend you guys to use, because it really optimizes your bandwidth. And especially the use of ASTC compression. It has been available for the last few years already, and now is mainstream on the smart devices shipped. And it's very efficient, so please use it. All these third-party tools, we have them available on command line executables and binaries that you can install on any third-party tool. And apart from this, we have all the developer guides, tutorials, SDKs, sample code that we provide for you. And how we do this is we first make the demos, we try and find new ways of doing rendering techniques, and then all our findings, we document them. And I want to show you actually a video on how we do it for 10 techniques.
An abandoned cave, home to an ancient lunar calendar, used at one point in time as a site for celebration. In the distant past, people would climb the mountain up to the glacier cave, and after paying their respects, rotate the statues of the zodiac animals around the calendar board. No one has visited the cave for thousands of years, but the spirit of the past is still alive.
So yeah, all these techniques that we did for this demo, and actually here now I have the other demo uploaded from Vulkan, all the sample code, the source code files for each of the effects, the same for these, are available online. So then I encourage you to go to our malideveloper.arm.com, and there go to under the tutorials or the SDKs or the sample code options, and then you search there. So basically we do our research and then we document all of that. And we do this for game developers using Unity or for game developers using their own engine or generic. All right, so any questions?
Hello. Sorry, as I know the OpenGL and OpenGL, yes, there are difference in restrictions on ARM, the mobile devices. I mean, in terms of using such API like usual, for example, it's less. So what's the benefits of using Vulkan if it uses the same OpenGL ES with restrictions and the same shaders? Or
No. So perhaps I explain incorrectly, or maybe how I explain it. So OpenGL is the desktop API, and OpenGL ES is a subset of OpenGL. But Vulkan is completely different. It's an API that works cross-platform. So it's not a subset of anything. So it's a new API that has been built from scratch. And actually the shader language of Vulkan is based in SPIR-V, which come more from OpenCL standard actually. SPIR actually is OpenCL, and SPIR-V is because it's for Vulkan. And this gives you more access directly onto the GPU. So they had to take this shader code rather than the OpenGL GLSL code from the API, basically. So the shader code is different. Actually, guys, I encourage you to have a look at the Vulkan API in closer details. The amount in this demo that we have here, the protostar that we did with Epic Games and Samsung, so the Epic Games engine supports Vulkan. It has increased the number of draw calls per frame like 2 to 3 times, and it can do even better, I'm sure, because Vulkan has just been released, and it's AAA quality game, lots of particles. You can see also the video clip on YouTube is quite impressive on protostar and Epic Games and Samsung. Thank you.
Thank you. Well, let's come up and take a look at her screen. Thank you.